Hello, everybody. Hello and welcome to this broadcast. My name is Darlin Basu, and I'm the chair of BCS, Central London and North London branches, two great groups. If you're not a member of BCS, hey, why not? Do look at joining up with us. And if you are a BCS member, you will know the benefits, so welcome to this session. This session is on a very important topic for us in the UK. It's about 5G in the UK. And we may have a number of sessions for you on this topic because it's so important. The first of these sessions is 5G vision from Intel. And we have an expert presenter, David Fraser, who is the Technical Sales Director of Intel Corporation UK. And this is a very open session, as it were. So what I'm going to invite you to do is to enter questions into the questions panel, which you have on the right-hand side of your screen. So if you have questions, please enter those, and either Dave or I will try to pick those up and answer them. If not, then you're welcome to email us later, and Dave will give his email at the end, or you can email to the BCS email address, or to me, darling.basu@bcs.org. Any further questions you have. But that's all very well. That's all very questioning. It implies that this session is going to be full of questions, and I hope it is. We currently have over 60 people registered and online, and I think it's really time for me to pass you over to our expert presenter, Dave Fraser. Over to you, Dave.
Thank you, Darlin, and thanks for the opportunity from the British Computer Society to present today. So as Darlin said, my name is David Fraser. I'm based here in the UK. I've worked with Intel for 22 years. During that time, mainly been based here in the UK, but I have spent some time overseas, both in the US and Europe with Intel. For the majority of the time, I worked in the OEM business, so supporting a large multinational hardware OEMs. And for the last 6 years, I've been part of the network and communication sales organization, which sits within the data center group at Intel. So today I wanted to talk about our vision for 5G, what it means, and try and put a UK flavor to that. It will really be looking at, what's going to change society with 5G. What are some of the opportunities? How it will benefit society in that respect. And as Darlin alluded to at the beginning, if there are, if there is interest to come back in a future date and maybe dive into some of the more deep technical elements to 5G and what we're doing from our products and technologies, then that's something we're open to do as well. So okay, let's just jump in. So just wanted to start with kind of just to get the minds thinking of some of the diversity that 5G technology can be applied to today, and sort of pose the question of what connects fish farming, oil pipelines, video surveillance, and the whole raft of other potential use case scenarios. And as the title says, there may be few answers, but one of them is certainly data, right? And I'm sure a lot of people have seen the terminology, data is the new oil. I've certainly seen our former CEO using that, and it was interesting when I first heard this phrase being used. I did a bit of background research on it, and I was surprised and pleased to learn it was attributed to the British mathematician and architect of the Tesco's Club card, Clive Humby, in 2006. And since then, it's been repeated and amplified, first by marketeers, then by entrepreneurs, and ultimately by business leaders and policymakers. And why I was wanting to use this in the context of our talk today on 5G and edge computing, and the way I think of it is, if data is the new oil, 5G and edge compute are the super tankers and the refineries. So without an ability to move the data and to process the data is relatively of low value, right? So very similar to oil in that respect. And 5G becomes that pipeline, if you like, in the sense of either a pipeline or a tanker, and the edge as a compute node becomes the refinery in a way to extract value from that data close to the source of the data and provide low latency insights to that data that you can collect. Okay, so we've caught a glimpse. We've probably seen the potential as carriers have been rolling out coverage for 5G in cities across the world. However, the true impact of 5G is just beginning. There's certainly a bigger picture here. It's not just about connecting people with data or people with people. It goes far beyond faster smartphones to connect billions of smart devices with billions of other smart devices. It converges the world of computing and communications to create virtually unlimited compute power from the cloud to the network to the edge. So 5G conversation is has or traditionally been focused around wireless, but I feel that's not the whole story. Much of the conversation around 5G is focused on wireless improvements. The work on wireless is important, but it's not the whole story. In fact, wireless is just one component of a much bigger picture. 5G is taking the industry beyond communications. And when you zoom out, you see that a fundamental paradigm shift in computing and communications is underway. What happens when compute is everywhere? It provides a springboard to a range of new and enhanced services. It changes the way we connect with the world as systems and processes adapt and learn in real time. It transforms our cities and our industries while driving disruption and creating opportunities around the globe. Like 4G enabled the mobile app economy, 5G is enabling a whole new wave of innovation and business transformation, but on a much larger scale. In fact, transformed 5G networks are forming the infrastructure for a fully connected, mobile, and smart society. History has proven that technology is the catalyst for massive societal transformation, and the technologies at play right now are incomparable to the technologies that have come before. The rise of AI, the emergence of the edge, the massive amount of Internet of Things data, and the transformed mobile networks. These powerful advancements are coming together to open up previously unimaginable business and financial opportunities. And businesses that adapt have a chance to provide their customers with better experiences, transform their operations for gains in productivities, or even disrupt their industries with entirely new services. We've seen technology change industries before. Consider what happened in the 4G domain, the sharing or app economies, and how that gave rise to business entrants like Airbnb and Uber, who were powered by smaller technology paradigm shifts, but those new digital business models ushered in by personal computing, the internet, ubiquitous connectivity, and smartphones gave birth to whole new economies, and some of the most successful companies that we now see on the planet. And 5G is about to do the same. Arguably, it may have even greater impact. In fact, it's estimated that by 2035, the 5G industry value chain will be worth $2.5 trillion. And while that's impressive, it's nothing compared to the global economic impact or output 5G will create across industries, including perhaps the industries you work in. By 2035, the multiplier effect of 5G will produce $13 trillion of revenue. Okay. So what are the trends driving the need for 5G? Well, firstly, the Internet of Things. This enormous network of connected machines is transforming how we monitor, manage, and produce things, and it's generating a massive amount of data. In fact, IDC predicts that IoT devices will generate more than half of the world's data by 2025. Combined with cloud computing power, all of this IoT data can feed an AI engine. That engine delivers new levels of machine-to-machine coordination that can improve lives and accelerate economic growth. But a world where billions of things become smart and connected won't work on 4G networks. They weren't designed to support all the data traffic. More capacity is needed to scale. Capacity to handle huge networking workloads akin to building a bigger pipe is required, but capacity in managing the number of connections as well has to expand. Second, video is huge. Video creation as well as consumption and sharing. How many times have you been at a stadium, for example, Wembley or Twickenham, and your cellular devices showed full bars, but you have zero connectivity, right? Which is frustrating. Or been watching a pivotal moment of your favorite Netflix show when it stops to buffer. That frustrates us all. Video streaming will soon account for more than 80% of internet traffic. Flexible 5G networks with high data speeds in the terms of gigabits per second, along with Visual Cloud, are ideal for allocating enhanced capacity at events and streaming high bandwidth content, not to mention facilitating the proliferation of new immersive media like 3D volumetric video. So I think it's easy to imagine what a stadium or venue experience could look like if you had limitless bandwidth and the types of experiences producers of those events could offer to the customers. You know, for example, we've seen experiments and proofs of concept where it's been able to take the attendee and actually bring them into the field of play or onto the stage at a concert. And these things can be enabled with 5G bandwidth and actually, you know, give you that perspective of being in the game or being on stage with the artist on your handset at those events. So these are some of the options that people are looking at and how to use the connectivity, the improvements in connectivity, and to provide them in these dense environments. And then for media and broadcasting companies, 5G means the ability to explore different distribution models like direct delivery or enhanced content with the certainty that high-speed mobile networks will deliver an experience consumers will love. Lastly, one of the biggest game changers for 5G is the ultra low latency it will provide. Human communication can accommodate a lot of latency, and we can still understand each other. When machines need to communicate directly, whether robots or on a production line of remote controlled excavating equipment, ultra low latency is required. Sorry, I think this, somebody's moved this file, just one sec.
Yeah, Dave, if you just click on full screen again. That's it, fine.
Okay. Okay, thanks. Okay, so 5G mobile networks will be able to deliver ultra low wire-like latency that opens up a whole new ballgame in terms of usages, like controlling machinery remotely, introducing risk to humans, One example of that we've seen already in 5G is using 5G enabled robots to enter mine sites shortly after explosive activities have happened. So when they've been doing blasting and mining, they obviously have to leave the area clear for a number of hours until things are stable. The air content can be refreshed. However, robots can enter those environments immediately. So again, it's a way to enhance safety in those areas and increase productivity. Okay. Again, another example: esports players will be able to play from anywhere, and even use cases like remote real-time controlled surgery are all being explored using 5G technology. You probably heard that 5G is different from previous wireless generations. Well, why is that? Because 5G marks the moment when two powerful technology trends come together. The first trend is the evolution in computing, from the personal computers that dawned the internet to the mobile and cloud computing of today. The second evolution across wireless generations: 1G gave us the analog phone, 2G gave us moved us from analog to digital for voice communication. 3G gave us data connectivity and mobile applications, and 4G has given us ever-increasing mobile broadband speeds. As you can see, computing intersects with wireless as we enter the 5G area. That's because 5G is the convergence of computing and communications. With 5G, the cloud, network, and edge all become hyper-converged to operate into a single entity of computing where data intelligence and services are distributed dynamically. While previous wireless technologies were defined for advances in phones to connect people with people and people with data at faster speeds, 5G was defined beyond the smartphone. 5G is the first wireless technology that was designed for other use cases that can now go untethered and wireless. These use cases are being enabled by 5G's ultra-fast speeds, ultra-low latency, and massive capacity. 5G is delivering three key features: enhanced mobile broadband, EMBB, ultra-reliable low-latency communications, URLLC, and massive machine-type communications, MMTC. Enhanced mobile broadband enables bandwidth-driven use cases. These are the use cases that need high data rates across a mobile and wide coverage area. Think compute-intensive media applications like real-time immersive 3D video. Ultra-reliable low-latency communication facilitates mission-critical, like time-sensitive factory automation and autonomous vehicles and autonomous driving. Massive machine-type communication connect massive amounts of devices that transmit intermittently, such as with Internet of Things devices. All of those features are monumental, but as we've seen, the difference between 5G and the previous wireless generations is much more than faster speeds or lower latency. 5G is about enabling a whole new paradigm of distributed, intelligent computing. 5G is changing the paradigm of computing. Compute is no longer being siloed in centralized data centers. Instead, computing and intelligence are being distributed across a reimagined network. The reimagination of the network is key. That's because 5G and the experiences that distributed computing enables can only be as powerful as the network that supports them. From the cloud to the core network, to the radio access network, and all the way to the edge, an evolution is happening. We're moving from fixed function appliances to cloud servers, essentially running a network application. What this means is we're extending the power and flexibility of the cloud. It's similar to what happened when we moved from flip phones to smartphones. The former was designed to do one thing: make voice calls. With a smartphone, voice calling is just an application, and your smartphone has become a flexible computing device in your hand. Similarly, traditional equipment running networks up till now has essentially been appliances. These devices were designed to do one thing. With virtualization, Intel-powered cloud servers have the flexibility to change workloads based on demand, and we've seen cloud providers really push the limits of what you can do with the virtualized cloud architecture. This is how we are distributing compute and intelligence across the network. Cloud servers are being deployed across the network to handle a myriad of networking functions that are becoming virtualized and software-defined. They bring with them the computing power to run new applications and services, including artificial intelligence, over more agile, optimizable, and scalable networks. What's more, these networks have the potential to become self-managed, intelligent enough to recognize and adapt in real time to the specific requirements of the user use case and provide the service automatically. In addition to that, those networks are able to identify where there's faults in the networks, or even identify before a piece of equipment goes down and swap it out or reroute capacity onto a different node. So the self-optimization and self-healing that's brought with artificial intelligence can really benefit the network operator in that respect, and the customer by providing better quality of service.
Dave, we have a question. Catalan Alexandru asks, is the low latency low enough to replace the under-ocean network cables? So there's a subterranean question for you. Could you advise?
Yeah, so I don't think the backhauling which the under-ocean or subterranean cabling is providing will be universally replaced by 5G. 5G can provide backhaul technology over shorter distance, and obviously undersea cabling is going over hundreds and not thousands of miles, which is beyond the range of 5G signals. So I don't see it universally replacing it. If you hold the thought, it's an interesting thought as well. And a slide that we'll come to, we've got a bit of an oceanographic theme there. So we'll talk a little bit about where 5G could maybe play a role in providing connectivity to ocean-based activities. But I don't see it wholly replacing undersea cables. Okay.
Thank you.
Okay, so one of the things we're doing at Intel is we're delivering the technology foundation for this reimagination of 5G infrastructure, from access to edge to core, including unique network acceleration and AI innovations. These are tailored and tuned for new reality of real-world workloads and services. And with our history and heritage as a leader in cloud computing, we're transforming 5G networks and becoming part of that fabric in the same way that we are part of the fabric of the backbone of the data center. The next compute paradigm is bringing together wireless computing, the cloud, and edge, and innovative technologies like artificial intelligence and the Internet of Things to create a unified technological foundation and a scalable global marketplace. And the timing is perfect. What do I mean by that? It has to do with the increasingly massive amounts of data our world is creating. In fact, IDC predicts that the amount of global data generated will reach 175 zettabytes by 2025. This new reality of data demands requires a reliable, real-time system to move, store, and process all of that data. 5G's ultra-reliable and ultra-low latency capabilities can facilitate those demands across data networks and unlock a range of new applications from immersive VR to factory automation. The next paradigm of computing is creating an adaptive, predictive, and autonomous world. It's in this world, wireless networks will enable real-time and fully reliable connectivity. They will no longer be a bottleneck. They will facilitate exponential or increasing interaction loops between people and things, and they will make workload requirements dynamic and application controlled. This will be true on a broad scale and a local one. With distributed compute and the applications of new spectrum models such as locally licensed spectrum, wireless networks will enable new local ecosystems. The performance will meet local network criteria for enterprise and factories, reducing costs and creating flexibility. To achieve this, networks fundamentally alter their design to become fully distributed computers, leveraging each networking node to its fullest. Intel's unmatched portfolio, optimized software, extensive tools, widespread ecosystem are enabling our customers to design, deliver, and deploy innovative solutions for network, core, edge, and access at scale. So, Dallin, shall I pause and take the question? I see there's another question came in there.
Yes, indeed. Tung Nguyen has been asking questions about the infrastructure. Can you see it, or would you like me to read it to you?
Yeah, if you could just maybe read that to me, that would be great.
Sure. He asks, could you talk a little bit about the infrastructure to support and implement 5G to gain full performance, please?
Yeah, so I think, just to sort of touch on the infrastructure. So what we've really been trying to describe is how there's a transformation in the network, and the network to support the new 5G standards has to evolve and transform significantly. And that's at all points in that network, from the radio access network, where we're introducing new antenna types, through to the virtualization that's being applied in the radio access network and the core network to increase capacity and performance in those elements as well. I don't really have time today to cover, what we're doing in terms of the infrastructure, as dig into that, and that might be, if there's general interest, that might be an area that we could either, look at offline if you want to email some questions to me afterwards, or if there's some specific interest about a particular piece of infrastructure, then we can address that offline, or it's maybe something that we could come back at a later date and talk about.
Yes, Dave, a later date sounds a very good idea for this. There are lots of aspects of 5G we want to deal with. And it looks like there are various questions coming in about Huawei, but I suggest we park those till a little bit later. However, it's obvious, says Tung again, that the price is going to be expensive. How do we deal with this expensive price? You might like to just make a brief mention of that, if you can.
Yeah, so I mean, I think, the thing that in any price model, it's, I think if 5G was to roll out purely on an evolutionary basis from 4G, by providing faster mobile broadband, then yeah, that would be a tough economic model for a mobile network operator to look at. Therefore, I think the capabilities that we've just started to explore and touch upon, where 5G opens up new business opportunities, that's really an additional monetization opportunity. And therefore, the types of costs of, to refresh and invest in infrastructure can be monetized through those new services, and growing the top line of the business as well as continue to monetize through standard consumer mobile phone contracts.
Okay, Dave, thank you. Would you like to do some more of your presentation, then answer further questions or to pick up questions now?
Let me go on a little bit, and then we'll come back to the remaining questions that we can answer. Okay.
Fine.
Okay. Right. So networks are moving from fixed function to become more virtualized and software defined as the power of the cloud is distributed all the way to the edge. This process is sometimes referred to as cloudification. Two of the key technologies underpinning cloudification are software-defined networking, or SDN, and network function virtualization, or NFV. SDN is about creating a programmable software-driven environment that provides agility to remove the hardware-specific limitation of legacy networks. NFV is the implementation of network building blocks that run over software for greater flexibility and real-time adaptability. This cloud-like transformation enables the benefits of next-generation networks. Not only will these networks unlock new services like network slicing, where we have a dedicated network slice tailored to meet the industry or application-specific requirements, but also they will be more efficient, agile, and cost-effective. In addition, the dynamic and real-time nature of these networks will distribute intelligence and resources where they're needed. This optimizes workloads and lowers total cost of ownership. And with a single architecture foundation, these networks will be extremely flexible and scalable. Even now, we're enabling our network customers to realize these benefits with world-class infrastructure and broad portfolio, including FPGAs and Intel Xeon scalable processors. With Intel technologies, our customers are laying the foundation to solve industry problems and create and deploy innovative services from edge to cloud in the 5G area and beyond. Cloudified networks aren't the only way that 5G delivers flexibility. 5G also delivers multiple options for deployment models that range from public to private. Enterprises can explore deployment options to access connectivity and deliver use cases with the level of control and investment they want. Let's talk about these options for a moment. So public networks are the typical model we see every day. Service providers, often called mobile network operators or carriers, deliver broad coverage across a wide area such as cities or nations and scale services to the subscribers as needed. Considering spectrum, the radio frequencies used by mobile wireless communications, public networks use licensed spectrum with a certain set of frequencies dedicated for each operator to provide their services. So these are the spectrum options that we've probably heard about typically. Starting with 5G, that licensed frequency spectrum now also includes millimeter wave, and we will see those licenses being put up for auction in the near future, I believe, in the UK. With the advent of 5G, service providers will be able to deliver and monetize public networks functionality in new ways. For example, network slicing is an emerging service that providers can offer enterprises to access dynamic end-to-end virtual network connectivity that is tailored specifically to meet their industry needs or use case requirements, like, for example, ultra-low latency or ultra-high bandwidth. So essentially what that means in terms of if you're an enterprise customer, you could contract with your service provider to have a dedicated slice of their network. So that would enable you to presentations. Okay. So yeah, that will enable you to have a dedicated slice of the network, which only you could use, and which you could be tuned for your particular set of criteria. So if you value and you need ultra low latency response, then a service provider could offer you a specific slice with a guaranteed quality of service that could deliver that for your business. If you don't need that for all of your applications in your business, you can contract for a certain bandwidth or a certain amount of service in that ultra low latency slice, but then use a more standard or off-the-shelf contract for the rest of your business needs. So it gives you a flexibility of tuning or customize the service option you can ask for from your service provider, or they can offer. Taking that even further, there is, of course, the okay, sorry. Taking that further is the option of moving to a completely private network. They're typical local area deployments that deliver targeted coverage to a limited area for a specific use case. Think about a smart stadium or connected factory. These networks give enterprises the opportunity to gain control over a dedicated connectivity. Enterprises have flexible options to set up a private network with varied levels of control and investment. For example, enterprises could deploy and manage their own on-premise mobile network that operates with locally licensed or shared spectrum, or they could deploy a private network operated over service provider licensed spectrum and have that service provider or a third party even handle network management for them. So it gives some flexible options, and what do you need as an enterprise for your connectivity, and if it's certainly in terms of private LT or private networks, it's an area that we're seeing a lot of interest in, providing things like campus or site-wide networks. So again, something that's an emerging use case and business model that's helping to improve the connectivity options and also develop new potential revenue streams for an operator or spectrum holder. While spectrum has been a barrier in the past, new options like in the US CBRS or unlicensed spectrum are emerging that provide availability and cost efficiencies. Public and private networks complement each other to deliver on use cases. Consider a smart stadium, for example. The owners can operate on an on-premise network for dedicated connectivity and control behind the scenes operations as well. At the same time, public networks provide connectivity to the fans inside the stadium. So, these things will coexist, right? They won't be an either or. It gives the opportunity to, to provide a customized solution depending on your needs. 5G is the next generation of cellular wireless. At the same time, 5G is a leap forward in technology and its revolutionary impact across industries. In short, 5G is both evolutionary and revolutionary. Making such widespread advancement possible requires a broad ecosystem of players to align on the path forward for 5G, down to its most fundamental features and minute details of implementation. That process is called standardization. And it's critical in telecommunications because 5G is truly global in scope and applications. 5G has far-reaching economic implications worldwide. 5G standards are paving the way for major advancements in the field of communication for areas as diverse as industrial automation, telemedicine, self-driving cars, and augmented reality. The third generation partnership project, or 3GPP, formulates the 5G technical specifications, which ultimately become standards. When you look at the top of the timeline above, you can see that standards releases have already happened and are planned for the future. Furthermore, each standard release sets in motion the production and deployment of 5G products and services. Generally, it's taken 6 to 12 months for the related products and devices to become available. There are 3 major releases to understand right now. Release 15 in 2018 marked the advent of 5G and enhanced mobile broadband. As a result, we're seeing worldwide 5G networks roll out and 5G enabled handsets devices like phones and PCs in the 2019-2020 timeframe. Release 16 in Q2 2020, which was delayed by the pandemic, the global pandemic, is set to accelerate 5G's efficiency and expansion by enabling ultra-reliable, ultra-low latency communications. In 2021, we'll start to see related deployments like smart factories and smart use cases. Release 17 planned for Q4 2021 defines more advancements in system architecture and radio access networks. Ultimately, this release and beyond will lay the foundation for many of the revolutionary use cases we've heard so much about, like connected cars or smart agriculture. In addition, at Intel, we participate in well over 300 standards groups worldwide, holding leading positions in various working groups in ITU, 3GPP, and IEEE, amongst others. Our involvement in these groups is diverse, providing proprietary research, reference designs, and insights to make the full potential of 5G a reality.
Dave, could I pause you there? Because we're getting a lot of questions about timing and target dates and so on. And they also relate to Huawei. Could we answer some of those straight away?
Yeah, I mean, certainly I think if you go on the timings, right, you know, as I said, it's around those three releases. That's when we started to release 15 was when we started the first 5G commercial deployments, but that's an iterative process. As we've seen with previous mobile technologies, there are incremental releases as we go forward. And release 16, which has just happened, and release 17 for the 3GPP standard will really advance the capabilities in the 5G network through the ultra reliable low latency communication this year. So devices coming out 6 to 12 months from now in a normal cycle, but obviously we're in a bit of an abnormal world at the moment. And then release 17 in 2021 will be where some of the other features you know, are deployed in the specification. So there's not a single date is the short answer. Refer to the release schedule for when new capabilities will be added to the 5G stack.
Okay, but having seen the questions relating to Huawei, if I read a little bit of the one from Prashad, he says, having seen various news feeds, I understand Huawei were way ahead of their rivals in bringing the 5G infrastructure to the market. But with UK and other countries banning Huawei, how long are we going to wait to get real 5G capability in the UK? Do you think Nokia or Ericsson or others are ready to support the CSPs now?
I think the short answer to that is we have a diverse ecosystem of partners that are ready to support the operators and the enterprise customers in bringing new 5G capabilities to the market. And I think with 5G and the evolution of networks and edge computing, we're seeing a much more diverse set of players in the market, and no longer, you know, just the traditional telco equipment manufacturers. Other manufacturers are able, especially in the radio access, as we move to more of a software-enabled radio. Other players can come into the market. Other players are maybe not familiar today in that context. So we've seen entrants into the market. If you look at, for example, in Japan with Rakuten, they're a whole new player coming into the market. They have built a virtualized radio based on some traditional suppliers, but also on some new participants coming in. So I think the industry is, you know, in a very healthy position in terms of the diversity of suppliers in the market.
Okay, well, thank you. On that note, Tom Savalas has asked, will the likes of cloud servers, for example, AWS, Microsoft Azure, etc., be used in 5G's evolution? Is the current software and web services fit for intended future purpose? Which I think you've touched on, but you might like to just answer that a little bit more.
Yeah, I mean, I think that's all, you know, if you look at all of those large cloud service providers, they're all looking at how they can address the telecommunications industry. You know, not just as a standard IT or cloud supplier, but you know, how can they move into other parts of that paradigm? So they are looking at how they can, you know, offer their own solutions into new or expansion areas for their business. So it is, you know, it's one of the, I think it's one of the focus areas for most of the cloud suppliers, how they can engage in the telecommunications industry.
Thank you.
So, do you want me to address any of the other questions at the moment, or shall we move on?
Well, I suggest you move on because we do want to see all of your presentation as well as answer as many questions as possible.
Okay.
So, yeah.
Okay, so let me sort of just build out this slide. Okay, so you know, just a quick reminder about you know, that's on the software side. That Intel is traditionally a hardware supplier, but you know, we are involved at every level of the architecture. We take a full stack, full solution approach to build a unified technology foundation that is integrated and optimized to deliver more value. We're committed to working with the ecosystem across the platform, from software, hardware, and standard interfaces to applications and services. Open source software is a key component element, enabling a robust ecosystem and collaborative approach across the value chain to accelerate the pace of innovation. Through commonly adopted open standards and open source software implementation, it is possible to create a market filled with interchangeable solutions and future applications of new technologies such as machine learning, AI, data analytics, automation, cloud technologies, 5G, and other wireless technologies. Building on the previous file, we understand the challenge of our telecom and enterprise customers face today to quickly develop and validate technology solutions. And we've created blueprints to make the development simpler and enable companies to go faster to market. Intel and its ecosystem of partners offer scalable end-to-end solutions and frameworks that provide solid business results today and lay the foundation for a more intelligent tomorrow. Because we are committed to helping our customers delivering the transformative promise of IoT, the edge, and the network, we have developed over 130 Intel IoT market-ready solutions, as well as frameworks to help businesses capitalize on the game-changing advantages of the Internet of Things and the edge. This has been made possible by the Intel IoT partner ecosystem. These solutions are optimized for data-intensive workloads. They are adaptable, tested, and ready for immediate implementation across multiple industries, including industrial, smart cities, retail, education, enterprise, and healthcare. On the network side, our solutions and frameworks enable communication service providers to move at a rapid pace in transforming their networks for 5G-enabled future. The select solutions for network transformation offer a faster and more efficient deployment path for verified, reliable infrastructure. These configurations support virtual network enhancements and help meet emerging customer workload demands. 5G's reach goes far beyond any previous wireless operation and generation. Because of that, its success depends on collaboration across a broader ecosystem than ever before. Intel is uniquely positioned to convene this evolving 5G ecosystem. We're bringing together leaders and innovators across telecom, cloud, IoT, and the enterprise to define 5G solutions, open source software, and standards-based technology. We're committed to working with our telecom customers to modernize and expand their networks with open architecture systems, unleashing the potential for new and evolved services. This year, half of the wireless core network will be virtualized, and analysts such as Deloro expect that number to jump to 90% by 2024. In addition, we've seen the emergence of new players, as I mentioned, such as Rakuten. We plan to deploy the first fully virtualized 5G network in the autumn of this year, with Intel Technologies as the foundation. We're fostering a vibrant and rapidly growing ecosystem of developers to empower 5G. Through the Intel Network Builders ecosystem, a group of over 1,000 members, including independent software vendors, operating system vendors, OEMs, telecom equipment manufacturers, system integrators, and communication service providers, we are accelerating the adoption of NFV and SDS solutions in wireless networks and public, private, enterprise, and hybrid clouds. We have trained over 20,000 developers through our Network Builders program worldwide. 5G has the potential to transform industries from manufacturing to retail to media, with new use cases and technology applications that enhance everything from operations to customer experience. We are participating in or have participated in over 125 5G and Edge market enabling trials and proofs of concept, as well as the first broad 5G deployments at the Pyongyang Olympics, all to help lay the groundwork for enterprises to realize these use cases and benefits. We also participate in well over 300 standards groups worldwide, holding leading positions. Our involvement in these groups is diverse, providing proprietary research, reference designs to make the full potential of 5G. We're also advocating for 5G policy globally, with efforts including the following: advocating for expeditious assignment of spectrum license for 5G worldwide, global spectrum harmonization efforts with the ITU and World Radio Communications Conferences, advocating for mechanisms to encourage increased investment in 5G infrastructure and to facilitate continued innovation throughout the 5G ecosystem, support mechanisms for financing of overseas exports. 5G networks and AI are two of the most influential technologies of our time. They're working together to infuse business and consumer experiences with powerful insights that unlock not only efficiencies, but also entirely new services and economic value. In fact, the global GDP from indirect, direct, and productivity value from 5G and AI will reach $17.9 trillion by 2035, according to ABI research. The chart on the right shows a breakdown of projected 5G and AI value in US billions from 2018 to 2036. It's clear that the 5G ecosystem and AI ecosystem are each independently demonstrating steady growth. However, what's most interesting is the skyrocketing amount of productivity value the technologies create together. In 2024, we'll hit an inflection point where the combination of 5G and AI creates explosive and potential exponential value. So how does 5G work with AI? The relationship is symbiotic. 5G distributes intelligence from the cloud to the edge to extract value from billions of data generating devices. At the same time, AI helps 5G by creating the potential for self-managed networks and dynamically adjust for optimal performance. The combined potential of 5G and AI leads to previously unimagined levels of insight, efficiency, and new revenue for businesses. From faster real-time optimized factories to predictive retail and inventory to smart city planning, their impact across industries will be transformational. With the billions of IoT devices connected by 5G, businesses are gaining access to massive amounts of real-time data to maximize the analytical power of AI for operational decision. In terms of efficiency, 5G can actually apply AI closer to the application to create the conditions for optimal performance. And 5G networks will extend AI to new applications so companies can offer new AI field experiences and services and even explore new business models. So we talked about fish farming on the first slide, and you know, I mentioned in the context of how 5G can help, you know, may offer some connectivity, but not as a replacement for the ocean or subsea cables. We are working with a company in the Nordics in Norway on a project where they are enabling 5G technology on their fish farming sites. And you know, if you look at the global fish farming industry, it's expected to generate something like 376 billion revenue by 2025. So it's a huge global business growing at a compound annual growth rate of nearly 5% between 2018 and 2025. And part of this collaboration is about moving into aquaculture, where we are able to offer real-time, high-quality video analytics in these fish farms offshore, and then backhaul the data to the land to where the customers or the analysts or the farmers reside, and they can process the data and check that the fish are healthy, there's no problems in the tanks or the pens, and able to improve their yields and in that environment and secure it from an ecological point of view. So as an example of where 5G would be applied here, the 5G would be providing the backhaul from the farm. These are offshore farms, so that would be providing the connectivity between the offshore farm and the land-based operator of the facility. Similarly, 5G and edge distributed compute it distributes computing throughout the network, bringing the power of the cloud closer to the end users to support latency sensitive application and rapid data transfer. And according to Gartner, 75% of enterprise generated data will be processed outside centralized data systems or the cloud by 2025. So the amount of data, data is moving to the edge of the network and will be processed there, which you know, creates some opportunities and challenges which we're all addressing. The edge offers options for enterprise computing beyond the traditional data center. While some applications benefit from high volume processing and storage of the cloud or data center, other applications benefit from ultra low latency and edge that the edge can provide. Running applications on the edge brings those applications closer to the point of service delivery, which can help enterprise enhance quality of service and generate actionable insights faster while overcoming the cost and complexity of data movement. So how do 5G and the edge work together? 5G makes the division of computing resources along the cloud network edge continuum possible, and its ultra reliable low latency capabilities make the shorter connection between the device and the edge even more efficient. Together, 5G and the edge deliver ultra low latency, agile scaling, and enhanced service for business. With high-speed 5G and the low latency of the edge, businesses can eliminate intolerable application delays and act on data insights in near real time. Businesses are also on the verge of unprecedented ability to test and scale new markets with the flexibility to expand compute power where it delivers the most value for the business. Furthermore, with the increased bandwidth and reliability of 5G and edge computing, businesses across industries will deliver seamless customer experience and even unlock new services. From zero delay cloud gaming to real-time traffic routing to fast data-driven manufacturing production, 5G and edge computing are working together to enable a new era of business innovation. And just building on the fish farming example, we're showing the architecture there where there's an end-to-end solution that has been developed in this context, from the cameras and the sensor technologies that are in the tanks, to the edge technology, so the FPGAs being applied to analyze and enhance the images from those cameras and sensors, and then routing that data all the way back into a management console in the control room to monitor things like this, the size of the fish, the count of the fish population. And one of the key things that in fish farming and this application is helping to improve is the detection of disease. Fish farming is very feed sensitive. If you're overfeeding the fish, then that encourages the growth of sea lice and which attack the fish. And this can provide a solution to optimally feed the fish in the tank, depending on the water quality and temperature. These things are also inputs into that analysis of how to feed the fish. So what this is a really practical example to address a very, very large marine aquaculture application, but it could be equally applied to, and in the context of the first slide, using video analytics in any sort of environment is an ideal candidate for 5G and edge computing and the AI that can be deployed at the edge of the network. Okay, so our world is generating more data than ever before, but we're utilizing a fraction of that data. 5G and the Internet of Things enable businesses to capture, store, and move data from massive amounts of devices at scale. In other words, they solve the problem of businesses leaving valuable data untapped. The Internet of Things is the enormous network of connected machines that is the result of adding connectivity to devices beyond traditional compute devices. By 2025, IDC forecasts that IoT will generate over half the world's data. Transmitting all of that data and realizing its potential demands the ultra-high capacity that 5G networks provide. The explosion of devices and data are becoming dependent on 5G to share that data and distribute intelligence to machines that enhance the experience, safety, and efficiency of our world. Working together, 5G and IoT create the potential for more shared data, computer vision at scale, and real-time optimization that positively impacts businesses. 5G is connecting more devices than ever, enabling businesses to act on a massive amount of data for decision making like never before. With visual IoT devices such as connected cameras, 5G is enabling them to access inference and intelligence. On a grander scale, 5G is connecting IoT to the edge and cloud for distributed computing. Using this paradigm, time-sensitive IoT applications can continually optimize. For instance, retail inventory updates to manufacturing supply chain monitoring to diagnostic imaging technology in healthcare, 5G and IoT will unleash the power of data to transform industries. So just as another example of 5G being applied, case study from Ericsson and the Fraunhofer Institute in Germany, where they looked at the manufacturing of bladed discs which are used in aero turbines, and they, through the work that they conducted in this using 5G as the communications technology for a real-time closed loop feedback system, the 5G enabled BLISC, or BLISC, so these are called bladed disc, case study alone could create annual savings of approximately 27 million euros for one single factory, and up to 360 million euros globally. And while the BLISC case is an extreme example, similar challenges exist within the manufacturing as a whole. Vibration and chatter during the milling is a very common problem. So what used to happen with these discs is, as the milling process was ongoing, it would drift out of tolerance, and that necessitated a 25% rework of each of the discs, which is a high rework level in any industry. And that's obviously limiting capacity and throughput in that factory. And vibration and chatter are very common problems in any metal milling process. There are about 5 million industrial sites in Europe, and compared with 4 million mobile base stations in the world alone. So, the applicability of this goes far beyond the manufacturing of these bladed discs for the aero industry. Equipping each industrial site with mobile communications opens up large opportunities for operators to expand their businesses. Current technology is not capable of supporting the solution. The main benefit of 5G in this use case is that it can provide very low, stable and predictable latency for real-time control. The sensor's information needs to be processed and acted upon within 1 millisecond. So providing that low latency closed loop feedback enables the milling process to be more accurate and less rework required. Miniaturized sensors and 5G communication models are also critical wireless data collection and the communication capability for cases like this one. In this case, the sensors are actually placed on the metal and monitored during the actual process to detect when there's excess vibration and it goes out of alignment or out of spec. The introduction of 5G will also bring more tightly controlled monitoring capabilities, meaning that the performance of a critical sensor, such as the bladed disc vibration sensor, can be monitored at all times. The potential for improving production economics for bladed discs is very high, and it's a revealing illustration of how incredible value can be realized when introducing high performance connectivity to the factory floor. The rework rate of bladed disc today is approximately 25%, and given their high cost, any decrease, the cost of these things ranges between 10 and 30,000 euros. And given that high cost, any decrease in the rework rate is of significant value. If they were able to move the rework, decrease the rate of rework from 25 to 15%, the machine time will in turn be reduced, which can be translated into a machine cost saving and reduction of 3,600 euros per bladed disc. The market for bladed discs is seeing strong growth. The typical bladed disc factory can only produce 40 per day, including rework. For one factory, the annual saving through real-time monitoring control enabled by 5G is estimated at 27 million euros. And it's around, assuming 100,000 bladed discs are produced annually, gives an idea of the order of magnitude. Bladed disc production alone is a significant metal processing operation, but only a fraction of total global metal processing. So beyond the production of this type of unit, the control application could be applied. There's also another benefit in sustainability. To give rise to decreased, if the rework rate could drive significant productivity gains in the factory, it will rise to decreased electricity consumption, which in turn means a potential decrease annually in CO2 equivalent emissions by 360 metric tons applied to the overall global bladed disc production. Higher quality bladed disc production also creates opportunity to reduce fuel consumption and thereby greenhouse gas emissions when operating jet engines. Increased production quality means bladed discs operate more efficiently, reducing fuel consumption and in turn lowering CO2 emissions. Assuming an average 2% higher efficiency is achieved, global CO2 emissions could be reduced by 16 million metric tons annually. These savings equal the total annual consumption-based CO2 equivalent emissions of approximately 1.4 million people. Or another way of quantifying these savings is compared to when 16 million metric tons of CO2 emissions is the same amount of 4.4 million people flying from London to Bangkok. Okay, so significant environmental impact and cost savings as well. 5G, along with AI, IoT, and edge computing, is transforming industries across sectors. The way we approach things like managing factory production, delivering healthcare to remote areas, and purchasing goods and services are all evolving and changing. This evolution is initiating ripples of impact that spur business opportunities, market growth, and the global economy. Those enterprise businesses that understand the 5G effect and how it can impact their industries are positioned to unleash promising innovation, disrupt their competition, and transform their operations. There are businesses exploring how to access real-time insights for actionable decision-making. These are the businesses exploring to enhance productivity with connected devices and automation, and even launch new categories of products and services that wouldn't be possible without 5G. 5G is ushering us into an era of precision manufacturing, or Industry 4.0 as it's sometimes called. This area is marked by automation and optimization, with access to real-time actionable data from billions of connected devices. In fact, over 75 billion IoT devices will be installed by 2020, according to some forecasts earlier this year. This will create 3.7 trillion in annual economic impact for factories. In manufacturing, productivity is a crucial factor for success. With 5G's enhanced connectivity and ultra-fast speeds, technologies like computer vision that depend on high bandwidth can intelligently automate complex workflows and processes. Production is easier to turn off and on based on demand, which increases efficiency and output. From an overarching business perspective, the ubiquitous connectivity of 5G enables constant and iterative optimization of processes from shipping and logistics to production schedules. This is because 5G connectivity, even for the smallest sensor in remote locations, coupled with real-time edge processing, makes factory and industrial data more accessible. These benefits extend to factory machines themselves, with 5G maintenance becomes proactive and predictive. Using 5G enabled edge computing and AI, manufacturers can resolve problems before they cause failures on the floor for less downtime and improve productivity and cost savings. In fact, predictive maintenance can reduce machine maintenance costs by up to 30%. With 5G, manufacturers can help keep factory workers safe. They can choose to delegate the most dangerous tasks, such as inspection after detonations in mines, to autonomous vehicles or remote-controlled robots with access to highly reliable, ultra-low latency connectivity. Furthermore, scores of factory data and surveillance drones enabled with computer vision can help to proactively identify risks before accidents happen, helping to make sure everyone on the factory floor is safe. And to go back to the first the oil pipeline example, one of the very common inspection methodologies now is to use drones to inspect oil and gas pipelines and overhead cables. So again, this is a very sort of common area that people are looking at, how you can use drones or robotics to enhance inspection procedures.
Dave, may I jump in for a moment, please?
Sure.
We have a question relating to this. Are law changes foreseen or being made to allow 5G's road plan to be unhindered? And this probably relates to your mentioning about drones and other surveillance methods and so on.
Yeah, I mean, I'm not obviously, in the legal side of things, how that manifests itself in terms of legislation. I think the one thing I would say in terms of the commitment from government and other entities is really about how we can bring the benefits of 5G to the market and to society as fast as possible. So while I can't really offer an answer on the legislative process around drones, but I think we've certainly seen an appetite from government to embrace 5G technology and move it and support it through some of their own investment initiatives like 5G Create and the various the 5G test beds and trials initiative in the UK, which I think was allocated £200 million in the budget. So there is a lot of investment there, which we've been working with some of our partners with, but yeah, don't know specifically about the drones.
Okay, may I ask you another one now?
Sure. Okay,
and this is from Adrian and from Prasad. They relate to the safety of 5G and the impact on humans, animals, etc. What research has been done, and have safety recommendations been prepared, or are they being thought about?
Yeah, I mean, I think with any, it falls within the construct of any wireless communication technology. It has to go through standards approvals, which take into account the safety and potential impacts it could have on people, animals, and the environment, right? So all of those criteria are were built into the discussions that happen within 3GPP and ITU around the safety of using technology at these frequencies, and individual governments are happy with the way those technologies are, what they offer in terms of any the safety records about looking at those technologies in context of the microwaves, etc.
Okay, well, Rosie, I have a cat called Rosie. She's just appeared and meowed a question to me. Is 5G likely to have any detrimental effects on little furry bodies?
I have a cat as well, and she's told me she hasn't expressed any problems so far. I mean, I think how it impacts some of the if there is any impacts to animals that are listening at a higher frequency than us, I have no idea. I think I would certainly rely on the guidance and the direction that we're getting from the experts in the 3GPP and ITU who have been evaluating these technologies and microwave frequencies for many, many years, that these are safe technologies for everyone, including cats.
Okay, thank you, Dave. It's 12:21, and we need to finish within the next 9 minutes. We
sure.
have one more question, but can you just go through the rest of your slides fairly rapidly?
Sure, yep, I'll do that. So looking at additional immersive experiences, the media and entertainment industry is transforming. Subscription-based services and video streaming are dominating the industry. In fact, we expect that 80% to 82% of mobile traffic will be video by 2022, according to Cisco. The shift from a broadcast to a broadband model is enabled by increasing access to fast 5G networks. 5G is unleashing new and enhanced immersive media formats and experiences, fundamentally changing the way to create, consume, and share content. There are compelling opportunities emerging from this transformation. We project the value of 5G-enabled immersive media like AR, VR, and cloud gaming will reach $18 billion by 2025. While overarching global 5G mobile media revenues will reach $756 billion by 2028. 5G cloud gaming is becoming truly next level. The ultra-low latency of 5G is enabling media companies to enhance experiences for gamers with console quality, near zero delay cloud gaming from anywhere in the world on any device. This isn't just your run-of-the-mill gaming content. Gamers are becoming empowered to stream ultra-high quality video in real time. Eventually, they'll enjoy features like 3D volumetric video with haptic feedback, ultimately creating a new realm of curated cloud gaming services. The value of the video streaming market will reach nearly 125 billion by 2025. With 5G's ultra-reliable coverage and ultra-high speeds, consumers will be empowered to stream high bandwidth, high-quality media like 8K video with flawless graphics without any lag. And to realize these new media use cases, we need to meet skyrocketing demand for compute-intensive visual workloads. The ultra-low latency and ultra-high bandwidth of 5G combined with 5G computing, AI, and the visual cloud have the power to move, store, and process the new reality of visual data, workloads, and services. Service providers can even use their existing network infrastructure to monetize content delivery networks, CDNs, and facilitate media use cases in effective and efficient ways. One other example of how 5G is a potential use case for 5G is in broadcast media, where instead of having to roll a truck out to a news location or a sports location to do an outside broadcast, 5G has been seen as a way of backhauling from that camera. So essentially, camera, sound, and the reporter would be all it needs to provide a high quality outside broadcast, and then using the 5G bandwidth to backhaul those pictures and sound to the studio for post-production. And then moving into retail, there are two worlds of retail right now, the digital and the physical. The internet revolution brought seamless online shopping experience, easy product and price comparisons, personalized offers, quick checkout, and meanwhile, traditional brick and mortar retail offers tangible interactions with products and an opportunity to try before you buy, another form of convenience. 5G, AI, and IoT are helping retailers get the best of both worlds. These technologies are bringing physical and digital retail together to create an omni-channel revolution. This revolution delivers opportunities to engage shoppers with more personalization, increased sales, and reduce costs with highly curated, customized, and unified experiences from online to in-store. In fact, the value of the global smart retail market will reach $58.23 billion by 2025. The omnichannel era of retail delivers one seamless experience. 5G and edge computing enable computer vision and AI to extend the highly personalized nature of online shopping to physical locations. Take smart signage, for example. When a customer walks by the smart sign, considers browsing history or shopper demographics, then it creates an AI-generated profile for instant targeted offers and discounts. To add to the elevated service, computer vision can even detect customer moods and alert sales staff to provide assistance if necessary. Behind the scenes, retailers can enhance operations to boost productivity and efficiency. The high speed and ultra low latency of 5G networks and IoT sensors help retailers to streamline operations and supply chain logistics from material sourcing to final sale in the near future. Stores will also be able to track inventory levels and automate restocking with smart shelves while predicting demand and optimizing pricing with AI. Not only does this reduce out of stock instances, but it also increases profitability. Frictionless checkout is where we can make it easier that retailers can make it for shoppers to purchase, the more likely they are to get the sale. Retailers can even use smart payment technology over ultra-reliable 5G networks to eliminate the problems of long checkout lines. That means customers can pay without talking to any staff, or even pulling out their credit card, creating a frictionless checkout experience in the store. This capability clearly has become more relevant in light of the current global pandemic. So just in conclusion, we're bringing the power of Intel technology to 5G, distributing compute from the cloud to the network and to the edge, because we see a much bigger picture than simply faster phones. We see a data-centric future marked by a fully connected and intelligent society. And just to wrap up, thanks for the opportunity to present this morning, and I'm happy to follow up offline with any questions that we don't have time or we haven't addressed so far, given we're 2 minutes from the bottom of the hour. So thank you. Dalim, any closing comments? Okay, if not, well, I'll close the call. I'll provide my email in the questions and answers, and if anyone would like to drop me an email afterwards, feel free to do so. Thanks very much for your time.